Brad Williams, Frugal Finance, interest rate parity. This is going to be a very, very long session. We're going to cover net present value, looks like bootstrapping, and a couple other mathematical challenges. And I'm going to leave some blanks in this because when we get to future courses, it's going to be some duplication. Here, this is going to be more of a practice session. Why? Because when I was doing this a zillion years ago, I ran into a lot of what ifs. And those what ifs I quantified through practice. And I decided to include the practice in this session. In other words, just some verification. Maybe it'll work for you, maybe not. It helped me. But you're going to say, well, I'm not interested, A, or B, Brad, that's pretty basic stuff. Or C, you learned enough from the previous sessions that you're just going to read this initially or listen to this for the first few minutes and then move on to the next sessions. So with that, consider two countries with debt instruments issued in the currency of each country and the spot and forward currency exchange rates in the two currencies. The interest rate parity theorem asserts that the interest rates in the two countries and the exchange rates between the two currencies form an integrated system. There must be parity in this system of interest and exchange rates to avoid arbitrage. Specifically, interest rate parity asserts that investments in one currency must yield the same proceeds as the following alternative strategy over a given investment: the law of one price. Convert funds into a foreign currency at the spot rate, today's rate, at the outset. Invest in the foreign currency. Reconvert the proceeds to the original currency via foreign exchange forward contract initiated at the outset of the investment horizon. To convert the investment proceeds into the original currency at the investment horizon. What's critical here is you implement that forward contract at the very beginning. So let F for foreign exchange forward contract initiated at time T with delivery at time cap T, the value of 1 unit of the X currency in terms of the Y currency. Thus, S euro F of X, that's going to be some currency, the forward exchange value of $1 in terms of euros for a contract initiated at time T is equal to 0 with delivery at time equals 3. And S looks like yen. The spot price, $1 in terms of yen for immediate delivery because T is equal to TB. Previously, we introduced the notation of zero coupon factors such that Z of T, T is the factor for payment to be received at time T measured from time T. I know, you're going, my God, we have to go through the weeds in order to get through all this. Look, there's I could just say, let's just follow this particular formula. But some of you have, enjoy this particular method. For those of you who don't, then look here. Interest rate parity looks like our 0 is going to equal F of X, Z times F of X. Again, in English, this theorem says that investments in currency X from time T until time cap T must have the same proceeds as converting funds from currency X to currency Y at the foreign exchange spot rate. Investing in currency Y from time T until time cap T and converting the proceeds of the investment in currency Y back into the currency X via forward contract initiated at time T with the payoff at time T. This wouldn't work unless you have that forward contract in place. To illustrate this parity condition, assume that the foreign exchange spot rate between the dollar and the euro is 1 to 0.8. The 1 year US interest rate is 9%, and the 1 year European EMU interest rate is 12%, all with annual compounding. Interest rate parity asserts that the 1 year foreign exchange forward rate must be 1 euro equals 1.21 or 1 minus 0.822018 equals 1.12 times 0.8 divided by 109. Here we have these two formulas. What does it look like? This is what we just absorbed right here. 109 equals 0.8. So we have this EMU rate. We use 12 and 9. If rates are 5%, and if rates are 8%. We're looking at foreign exchange forward rates. Here's that 121 number, and we come up with 109.8 times 1.12. That's the forward rate. We just went backwards to come up. All we did was B53. This is sort of a verification. B53 times 0.8 times 112. And then this is just simple manipulation. All we're doing, playing around with some numbers. I do it a lot. So this is just, if you just replace, this is just simple stuff. If you want to see what it looks like, it's 0.822018. This will be, or the euro. This is just verification of this other information. And then you can substitute all this you want. Then over here, we have this same thing, 108, and then we're changing, all we're doing is changing rates around here. Okay. And if rates are 5 and 8, we're going to see this change. And then if rates are 5 and 8, all I did was change the numbers around. This is just your forward exchange rate, your zero coupon factor, and your zero coupon factor, your euro zero coupon factor, and then your zero coupon factor. If interest rate parity did not hold, arbitrage would be possible. For example, if euro was less than 1.216518, in this situation, investments in dollars would be clearly superior. If the euro was greater than 1.216518, investment in euros would yield a higher return. Arbitrage would proceed by borrowing in the currency in which funds are relatively cheap and investing in the currency where the return is relatively high, with a forward contract to convert funds to the currency that was borrowed originally. For example, assume that the forward exchange rate is euro 1 to 130 US. The other variables are as given. One would transact as follows: borrow $1 million in the US for 1 year at 9%. Exchange $1 million for euro 800,000 at the spot exchange rate. Invest 800,000 1 year forward at €1 equals 130 for a total of 1.1648. Net cash flow equals 0. Year 1, collect proceeds of European investment. 8% times 1.12 equals 896. Deliver 896 against the forward contract. Collect 1.1 million. Repay U.S. loan 1 million times 1.09 equals 109. Net cash flow $74,800. This is a clear example of arbitrage, as it produces a riskless profit without investment. It should be borne in mind that interest rate parity expresses a relationship among interest rates in two countries, the spot exchange rate and the forward exchange rate. All four elements must be mutually consistent to avoid arbitrage. Consistent with interest rate parity, there is a term structure of foreign exchange rates. The term structure of interest rates in two countries and the term structure of exchange rates between two countries form an integrated system that must be consistent with interest rate parity to avoid arbitrage. For example, assume that the term structure of interest rates in the U.S. is strongly upward sloping, while the term structure of interest rates in Europe is more gently upward sloping at a lower level. Table 21.1 shows the situation in a simplified form along with the term structure of dollar-euro exchange rates that is consistent with interest rate parity. Because the U.S. term structure of interest rate lies above the European term structure of interest rates, the value of the mark in terms of dollars must rise as maturities lengthen. So here we have this example. We have U.S. dollar interest rates par yield. Then we have U.S. interest rate zeros. And notice the formula here. We've gone over this, and we're going to go over it a couple more times in the upcoming sessions. Here we're going to have the euro interest rate par yields. These are given, and we're calculating this other stuff. We have the euro EMU interest rate zero. We're using equals 0.298. So I cheated. Down below is the calculation, and I'm going to fix that. Here we have the European EMU interest rate zero factor, and we're just using the same formulas as we have in the earlier sessions. Then we have the forward exchange rate of euro value of $1. So we have 0 forward forward rate, forward exchange rate of 0 of dollar value. If you're not certain what this is, go back and I explain it. So we have a forward exchange rate of dollar value to 0. We have forward exchange rate of euro value of $1. So we're going backwards and forwards. And then we have the 0 coupon factor rate. We have the given. Yellow means we're given. We're given this information. And then the 0 factor, the math is the same here as it is here. All we're doing is plugging, chugging. A fixed for fixed currency swap as a strip of foreign exchange forward contracts. With this background on interest rate parity, we can now see how to interpret a fixed for fixed currency swap as a strip of foreign exchange forward contracts. Consider a 5-year fixed for fixed currency swap with annual payments negotiated in the context of the interest rate and exchange rate environment shown in 21.1, right up here. And assume that determined dates occur at years 0, 1, 2, 3, and 4, with payment dates falling 1 year later. Assume that the notional principal is 100 million, equivalent to 80 million euro, and that the dollar payer promises to pay a fixed rate of 8.5%, while the European payer promises to pay a fixed rate of 5.3%. 8, 5. Well, just go with this one, the 5.3. These rates are arbitrarily set at roughly the midpoint of the two yield curves for the tenure of the swap. Later, we will show how to find the no arbitrage rates for this kind of swap. The first timeline in figure 21.6 shows the cash flows from the perspective of the dollar payer. In each year, 1 through 5, the dollar payer pays 8.5 million and receives 4.24 million. Got that? 8%, 4%, 8.5 on the 100 million, and this 4.2% as converted equals 4.24 million. The timeline also shows the exchange of principal at the inception of the swap and at year 5. The cash flows shown in the upper timeline of figure 21.6 essentially express the cash flows from the following portfolio of foreign exchange contracts. So we're going to sell 80 million euro spot at a rate of 1 to 0.8 for 100 million. Then we're going to sell 8.5 million euro 1 year forward at a rate of 1 is equal to 0.49824 for 4.2 million. Got that? Then we're going to sell 8.5 for 2 years at 4.984. So we have our cash flows, and then at the end, we're going to get our 80 million back. 4.984 is equal to 4240 divided by 8500. Got that? The cash flows for the fixed currency swap in the upper timeline of figure 21.6 are equivalent to this portfolio of 1 spot foreign exchange transaction and 6 forward exchange transactions. Notice that the foreign exchange rates for each year are the same, except for the last exchange of principal, and that they do not equal any of the forward exchange rates in 21.1. Therefore, we see that a fixed for fixed currency swap may be viewed as a portfolio of off-market foreign exchange transactions. Here we have the cash flow is recognized up here. And then we're going to have dollar perspective at 8.5 million. Then we're going to look at the euro perspective. This perspective also provides guidance to the pricing of this kind of currency swap. The second timeline of figure 21.6 shows the dollar equivalents of the cash flows in the upper timelines. All of the euro cash flows have been translated into dollars using their respective forward rates. For example, the euro inflow at year 3 is 4.2 million, and the 3-year forward currency rate is 0.726778 from table 21.1. Therefore, the dollar value of the flow is 4.2 million euros. Divide this by 0.726778 equals 5.833. In the second timeline, the exchange of principal is a wash. The dollar payer loses by at least 2 million on each of the annual coupon payments in year 1 through 5. The re-exchange of principal at year 5, 80 million euros for 100 million, implies an exchange rate of $1 equals 0.8 euro, which was the original spot rate. On the re-exchange of principal, the dollar payer recoups much of the losses on the individual coupon payments. For this fixed for fixed currency swap to be fairly priced, the present value of all of the cash flows in the second timeline must be zero. And these cash flows are discounted based on the US dollar zero coupon term structure. Otherwise, one side gains at the expense of the other. Similarly, we can view the entire transaction from the perspective of one concerned with euros. To do so, we convert all of the dollar flows into euros at the respective exchange rate. For example, at year 4, the euro payer receives 8.5 million. The 4-year forward rate is equal 1 equals euro 698078. So the euro value of the payment would be 5.93 million euro. Cash flows in the third timeline must have a zero present value when discounted according to the European zero coupon bond rates, the Euribor. Otherwise, one party gains at the other's expense. As we show later, this equivalence between a fixed for fixed currency swap and a portfolio of off-market foreign exchange transaction provides a valuable guide to pricing currency swaps. A plain vanilla currency swap as a fixed for fixed currency swap plus a plain vanilla interest rate swap. In this section, we explore the equivalence between plain vanilla currency swap on the one hand and a fixed for fixed currency swap plus a plain vanilla interest rate swap on the other. The plain vanilla currency swap calls for the dollar payer to pay SOFR against the fixed rate on a foreign currency. Consider a plain vanilla currency swap in the environment of Table 21.1. Assume that the swap has 5-year tenure and annual payments determined in advance and paid in arrears based on 1-year SOFR. The notional principal is 100 million, equivalent to euro 80 million. The euro fixed rate is 5.3%. Determination dates occur at years 0, 1, 2, 3, and 4, with settlement dates 1 year later. SOFR indicates the 1-year SOFR rate prevailing at time of T. This swap is the plain vanilla analogy of the fixed for fixed swap that we explored in the previous section. First timeline of figure 21.7 shows the cash flows for the plain vanilla swap. You can see there are a bunch of different examples. I'm going to give you a little preview here. What we see is just repeat. This right here, what you're trying to do is determine the net present value so it equals 0. But I'll get into that in a second. This you have seen. This will be testing purposes only. All of this is testing purposes only. Right here, testing purposes only. And then down here, it's going to say testing purposes only. And then here, it's going to be testing purposes only. There are 5 different examples similar to the narrative above. It's repeat over and over and over, but we are just moving things around. So the first example here will be US dollar payer euro prospective settlement date. Euro payer US dollar prospective settlement dates. So here we have euro cash flow, dollar SFR equals 9.3, euro FRA 5.60. We need to make sure this thing is equal to 0. Here's our cash flow. Here's our dollar cash flow. Here's our Forex rates. No magic here. All we're doing is euros per dollar, and this is just a discount. Then we have euro value of dollar cash flow. All we're doing is taking E80, this, times D, this right here, and this is just dollars discounted. Then we have euro cash flow, US cash flow plus, all we're doing is adding F180 plus 180, C180, there right here, and that'll give us the number here. Euro zero coupon factor, so here we have 1, and then 1.05 is just going to equal, we're going to go down. We're going to go down here, and I don't know why I referenced 295 so much, but we're looking at this number right here. What we're going to do is we're going to the present value 105. So we're going to take G180, this number, and we're going to discount it to the zero coupon factor. In the end, we're looking at this net present value equal 0. Why? Well, because we have to make sure that everything here is relative. In other words, no arbitrage. You can go through here and you can see how things are changed around a little bit. We're going to look at here, we have dollar value of euro, we have euro value of dollar, we have net dollar of euros. So all we're doing is switching things around. We got euros we got US. Down here, we're going to look at 21.4, cash flow analysis for plain vanilla currency swap. All right, remember this narrative right here? Well, we're going to just show you the cash flows. So the net present value equals 0. And then this is from the dollar perspective, and this is from the euro perspective. Testing purposes only here, where US dollar interest rate par yields. This information here is given. This should be yellow. Don't worry about this. Given, and this is just a copycat of it. All this is just the cash flows. Here is our bootstrap. And I'm not going to go through the details here. We've gone through this. If you're stumbling, move forward. This is my suggestion. Move forward through the rest of the sessions. There's a total of 28. Go through, see if you can start putting all this together. This swap fixed rate, this is our goal right here. This number right here. The math is going to be really the numbers up here, right here. We're going to be using the US dollar, and then all we're doing is discounting this stuff. So just keep in mind that really is the goal. These are just huge discount calculations. So we're going to take D224, which is this number right here, this 8%, and we're going to divide it by 0.238. You're asking what's 0.238? It's the bootstrap. It's this bootstrap zero coupon rate. And you remember, that's ultimately our goal. You always want to try to find this number, and all we're doing is going up, going down, going up. So remember, and I just keep saying that, if you just look at the second year, you're going to go 108.5, and that would be year 3. 100 minus 8.5 divided by 108. It's just going to give us our zero coupon factor. And the same thing, and just keep in mind, we have 109.3. That's this number here. Divide this by 100, minus 9.3 divided by 0.238, which is going to be the previous year, plus 9.3, and then 0.239. So we're going to go up the next year, and then we're going to go up and take 0.2, and then 9.3 over 241. All we're doing is discounting this for each year. So we're going to get this final number. And ultimately, we're going to just use the numbers to discount our term structure here. Okay, so we're going to go whatever this number is, D224, and then D225, D226, D227 by the zeros. Got that? This is the singular forward rates, and that's what we're ultimately going to check. So we have our forward rate. This is that notional principal, and we're using the bootstraps. So we're going to compute this number, and then we're going to do the exact same thing here. We're going to take D224, again, we're going back up here, times 1 times 1,000 divided by 0.238, our bootstrap number. We're just going to follow this pattern all the way across. So you can see we're using the par, but we're discounting 1 at the bootstrap, and then we're going to discount it at the forward, 0.238, 0.238. And we're discounting both at the zero rate. What's the bottom line here? 224, single forward rate. So here we're using this swap fixed rate, and to determine, well, the swap fixed rate discounted notional amount, then we're going to use, everything works around this bootstrap method. Then we're going to do this exact same thing with the forward rate, and we're discounting it by, again, the zero factor. Got that? And then here, our zero annual yield, and we're using log normals. 0.238 again is the zero, and we're just going to discount this. Then we have our annual coupon rate, and this is going to be fixed. This is going to equal this information. Why do I do this? It's just practice. You don't need all of this information. As you will see as we move forward, I compartmentalize everything, and I do all of this in what? 8 columns, and it's just clean and simple, and I don't show all of this other crap. This other crap, this right here, as I explained earlier, find the forward rate if you have the zero rate. In other words, this was one of those deals where I verify. You don't need to do this. This was just me, and I'm sharing it with you. Here, this is for the European EMU interest rate part. This is the second example, as noted above, and I'm just following the exact same process, but the numbers are going to be different. This is going to be par value, US. Then I went down and I said, how about the EMU interest rates? And here's the numbers that were given. and you're just going to plug and chug, and you're going to do the exact same thing. We have the 5.32 swap fixed rate. These have to equal each other. Find the forward rate and again, you're just going to shrug your shoulders going, why are we doing this? You don't have to do it. Here, the euro forward rate agreement to find swap fixed rate, you can just see the difference here. We have a swap fixed rate of 5.32%. Here we have a 5.59%. The question is why? Well, let me know. Comment. Notice the SFR is different from here, which is different from here. Why? Comment. And then lastly, I think we're going to have this plain vanilla swap. This is just for practice, testing, recognizing the pattern. And if you work through this particular example, all of them, then you're going to be well versed and you understand the logic, understand what we're trying to accomplish here, then you got it. And that's 99% of it is just understanding, connecting. It's a dot to dot to dot, connect the dots. The math is not that hard, but understanding the ultimate goal, no arbitrage. Brad Williams, Frugal Finance. Thank you.